Hi, and welcome to my video on finding the instantaneous rate of change. This is word problem number 2. I'm doing many examples for you to how to find the instantaneous rate of change, which is the slope of a tangent at a certain point or a certain time if you want, which is the slope of the curve. Here we go. The radius of a circle is changing at a rate of 8 meters per hour. Find the instantaneous rate of change of the area at 3 hours. Again, we have the rate that the radius is changing, and the rate is 8 meters per hour. So, the length of the radius, so we take the rate and multiply it by the time. So the rate, 8 meters per hour, multiplied by t hours. The hours cancel out, and I get 8t, and that's meters. That's the length of the radius as time goes by. Now we want to find the instantaneous rate of change of the area of the circle. So the area of the circle is pi r squared. So this is the area as a function of r. We want the area as a function of time. So we got the area as pi, and so the length of the radius in terms of time is 8t being squared. So that's pi. 8 squared is 64, and t times t is t squared. So we get 64 pi t squared. And its area, so that's the area is meters squared. Now we want to find the instantaneous rate of change at t, at the time of 3 hours. So instantaneous rate of change occurs at a point, at one time. But just to recall, the average rate of change you need 2 times, because the average rate of change is the slope of the secant. Instantaneous rate of change is the slope of tangent. So let's deal with the time is 3 hours, and also let's deal with one that's very, very close to it, is 3 plus 0.001. So 3.001 seconds is close to t. And so that should give us, as we've shown before, the instantaneous rate of change. Now because we have it very, very close, we're doing the average rate of change. Because it's close, it's becoming the tangent. So we have area is 64 pi, and t is 3, so it's 3 squared. So that gives us, that's a 9, and use your calculator, you get 1809.55. I'm writing all these down. So that's 3 hours, and I have this area. So I'm writing down the ordered pair, be consistent. Now I'm using this time, so the area is 64 pi, and the time is 3.001 squared. And when you work that out, you get 1810, and use your calculator. So 64 times pi is on your calculator, and 3.01 squared, and you should get this number. So that means that at 3.001 seconds, you're getting 1876.39.41. So the instantaneous rate of change is the slope. So the slope that the area is changing at is y2, which is 1810.763941. Subtract y1, that's the way I do it. is the rate of change. So it's y2 minus y1 all over x2 minus x1. And when you work at it with a calculator, you can work out the numerator, work out the denominator, and when you do that, you will get 1206.5731. If you use your calculator, put a bracket here, type this in, put a bracket, division sign, and put the two of these in a bracket. So if you're using the calculator on this fraction, put brackets around these two, division sign, bracket here, and a bracket here, and then press enter, and you should get this number. And that's close to 1207. And what is it? It's the slope. It's the instantaneous rate of change of the area. So that's the area, which is in meters. So that's meters squared. Whoop, like I said, cube. Meters area, meters squared per hour, h. So that's the instantaneous rate of change of this circle, whose radius is changing at 8 meters per hour at the third hour. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.